Hey, what's up guys, and welcome back. So I started working on a new game project called 5 PM, which is what you see on the screen right now. It all started when my friend Tev messaged me about creating a team and entering a game jam. I've actually never done a game jam, so I figured I'd give it a try. The game jam that we joined was called the Floppy Disk Jam, and called for games that were exceptionally small and could fit on a floppy disk. So basically they had to be less than 2 megabytes. This rules out using a lot of mainstream game engines because they create very large packages which would exceed this limit. We decided to use Tev's game engine, which he wrote completely from scratch in C. He has some devlogs about it, so make sure to check out his channel, which I linked in the description. My game engine only supports Windows, so it definitely wouldn't work for this project. Tev's engine is fairly complete in terms of providing basic graphics features like geometry and shader loading, but other than that, it's pretty minimalistic. As I will demonstrate though, you really don't need much to make a game with decent graphics. The theme of this game jam was infinite. Now the most obvious route would be procedural generation, and that's what we ended up doing. We decided on an infinite maze game, and the way that it works is each maze is a grid of cells, and they can either be filled or empty. The twist is that these filled grid cells are also themselves mazes, and you can enter them via doors on the outside. So this creates sort of a recursion of mazes, so to speak. This introduces the interesting mechanic that a maze that may seem unsolvable on the surface may actually be solvable by warping through these sub-mazes. On day one, we started with the basics with some stand-in assets and random maze generation. Tev added some player movement controls and some collision detection so that we don't clip through walls while we're walking around. And it was pretty bare at this point and doesn't really look like much of a game, but that was about to change on day 2. We noticed that the vertex lighting that was built into Tev's engine wouldn't work for this project, so I replaced it with a per pixel lighting system. Vertex lighting is poorly suited to this project because most of our geometry assets have very few vertices. We could have subdivided the geometry to add more vertices, but graphics hardware is pretty good these days, so having per pixel lighting shouldn't be an issue. As you can see, the lighting is much smoother, but it also looks a bit harsh, and this is mainly because I haven't added tone mapping yet, and we're losing a lot of dynamic range. I talk a bit more about tone mapping in my ray tracing video, and you'll see later that it'll fix this unrealistic look. I also started working on the main mechanics of the game, namely the procedural maze generation, as well as the ability to enter and exit sub-mazes. These purple boxes are meant to represent doors to enter a sub-maze, and the thin poles are meant to be the exit doors, which go between sub-mazes or exit a sub-maze. This is just for debugging purposes to be able to identify the exits and entrances. This was when we first started noticing some serious performance issues, especially when entering and exiting mazes. When mazes are generated, exits are placed based on whether or not there is an empty cell along one of the walls, otherwise it wouldn't be possible to spawn the player when they enter. There is a serious issue with this though. We need to render doors on the outside, and the only way to know whether or not a door should be rendered is to know the exact layout of the maze inside the cell. As the maze generation became more sophisticated, generating 100 or more sub-mazes when loading in a maze created a very noticeable lag. We solved this by instead generating the sub-mazes backwards. Each sub-maze has a random number of entrances, and this is very cheap to generate, so we can do it immediately when the player enters a maze. Therefore, we don't know or care what's inside until the player decides to actually enter a submaze, at which point we can generate its contents. On day 3, we started thinking a bit more about how we wanted the game to look, since it looked very temporary and the deadline for the game jam was approaching. I created some slightly more detailed wall assets, as well as textures for the floor and ceiling. I also added tone mapping to the engine shader, which softens the light and makes everything look a bit more realistic. When it's turned off, it really doesn't look very good, with some spots that are too bright and others that are too dark. Tev was also busy on day 3 replacing our stand-in door assets with this door model that he made. He also added a clock, which serves a very important purpose in the game. As you descend deeper into the maze, the clock will show a later time. You start off at 5 p.m. and the clock advances 1 hour at every level of the maze. The exit portal was also replaced with this brown door so you can actually distinguish it from just an ordinary door. Over the next few days, we focused on world generation, adding some more interesting structures like hallways. Notice also that as you descend deeper into the maze, your surroundings start looking a lot more cursed and spooky. You may have already begun piecing together what the story of the game is. In a sense, it's an allegory of being sucked into workaholism. And the object of the game is to escape and leave the office after the workday, but at various points you will be led deeper and deeper into the abyss of overtime, making escape more challenging. At this point though, we sort of stopped caring about the game jam. We were at a bit of a disadvantage because, as it turns out, submitting just JavaScript or HTML files was enough to satisfy the size requirements of the game jam, and this of course ignores the tiny detail that you need an entire browser to run your game, which conveniently you don't actually have to package with your game, whereas we were using C++, and in order to make a Windows build, just bundling the basic required DLLs already put us over the limit. We could stretch the rules a bit for the Linux build, and we did end up making a submission, and surprisingly, we actually did win, even though our game didn't really make a lot of sense. But in any case, the game jam wasn't really our main priority anymore. For the next few days, we worked on some performance improvements. Some levels can actually have a very large number of lights, and having 128 pixel lights on laptop hardware made the game very framey for certain users. So by using a simple scene graph and limiting each object to being affected by a few lights at a time, this problem can be fixed, and there's only barely noticeable artifacts. We also added the security camera object, which I'm pretty proud of. The camera has a simple AI that attempts to find the player, and the animation is also completely procedural, and it uses a basic spring simulation to make it look more realistic. Next, we started implementing stress. Now the idea is, when a camera sees a player, the player's stress level will increase. Cameras shouldn't be able to see through walls though, so we needed some sort of raycasting feature, and this allowed the player to hide behind walls and other objects to avoid being seen by the camera. In this game, stress is analogous to health. And to deal with stress, the player could find coins on the ground and use them in this vending machine, which I made in Blender. The final addition that I want to show is a somewhat hacky way of getting ambient occlusion using simple ambient occlusion volumes. These are rectangular objects that are spread out around the scene in key areas, and they darken the area around them. As you can see, the shader code is pretty simple, but these soft shadows add quite a lot to the look of the game, especially in corners and underneath the vending machine and anywhere else where you'd expect to see shadows. Alright, that's pretty much all the progress I wanted to show for today. Unlike my serial adventure game, this game is not actually open source, because we might actually sell it on Steam for a small price later. It's in very alpha stages right now, but we have a lot of ideas for improving it, and if you want to learn more about getting involved either as a tester or early supporter, check out my Discord server, which is linked in the description. Make sure to check out Tev's channel, since he's put a lot of work into this, and he definitely deserves a lot more subscribers than he has now. Alright, thanks for watching everyone, and I'll see you again soon.